Alright, this video is going to be a checkup or a chapter review of Chapter 2, and we're going to review a couple of different things. Let's first of all, let's go through and write some definitions down that we're going to need to make sure that we remember. So let's write down prime number, and a prime number is a number that is only divisible by 1, or you can write a number that can only be divided by 1. Alright, that's important. Only be divided by 1. And that number is called a prime number. Some examples would be 3, 5, 7, 13, 23. Okay, there is a lot of prime numbers. All right, the next thing that we're going to need to remember is something called a composite number. A composite number is a number that can be divided by numbers other than 1. Okay, so it's basically the opposite of a prime number. We can put a little star and write that. The opposite of a prime number. Okay, we need to also remember that the GCF stands for the greatest common factor. The LCM stands for the least common multiple, and that a factor is what larger numbers break down into. Okay, so now let's actually do some mathematics. We need to remember the divisibility rules, because the divisibility rules are kind of the basis of what all of Chapter 2 was about. Is the number divisible by 2? Is the number divisible by 3 or 4 or 5 or 7 or 8 or 10? All right, you have those rules written in your notebooks already, so I'm not going to go over them. You can find them and study them hard. All right, if you see a question and it asks this: find the factors for each number. And then it has some numbers like, let's say 125, and this is number 1, and number 2 would be 72. Okay, so it says find the factors for each number 125 and 72. All right, so what we're going to do is we're going to make a factor tree. When it says find the factors, this means make a factor tree. Okay, now 125 can be broken down into 5 and 25, which can be broken down into 5 and 5. So the factors are 5, 5, and 5. All right, so we can say 125 equals 5 times 5 times 5. What else does that equal? It equals 5 to the third power because we're multiplying 5 3's together. So that 3 5's get shoved into that little, what's called an exponent, okay? Exponent. We learned that in chapter 1. All right, so now let's do 72. So this is a full answer for number 1. Okay, so now let's do 72. All right, 72 is 8 multiplied by 9. 8 can be broken down into 2 and 4. 4 can be broken down into 2 and 2. All right, and 9 can be broken down into 3 and 3. Okay, so our factors are, let's circle everything at the ends of the branches here. 3, 3, 2, 2, and 2. Okay, so we can write 72 equals 2, cross that one out, times 2, cross that one out, times 2, cross that one out, times 3, cross that one out, times 3, cross that one out, and we're done. Nope, we're not done, because we can smash these 2's together and smash these 3's together, and we get 2 to the third power, because there's 3 2's, multiplied by 3 to the second power, because there's 2 3's. And that is a complete answer for finding the factors. Okay, so if a question asks you to write the multiples for each number, what's a multiple? A multiple is a number that's bigger than another that can be divided by that number. Now that sounds really confusing, but I'm going to explain it. Say we have the number 5. What's a multiple of 5? Start counting by 5's. 5, 10, 15, 20, 25, 30, 35. They're all multiples of 5 because 10 divided by 2 is 5. 15 divided by 3 is 5. 20 divided by 4 is 5. 25 divided by 5 is 5, and so on. Okay? So when it asks you to find the multiples, all right, just count by that number. Just count by that number, all right? And you will find the multiples. Okay, if it asks you to find prime factorization, prime factorizations, you're going to do a factor tree and you're going to circle your final answer. Okay? So let's find the prime factorization of 120. 120 can be broken down into 10 and 12, which can be broken down into 2 and 5 and 3 and 4. 4 can be broken down into 2 and 2, so we're left with a 2, a 5, a 3, a 2, and a 2. So let's put them in order from smallest to largest. So say 120 equals 2 times 2 times 2, that's the 3 2's, times 3 times 5. All right, so we can smash these together and we can say 2 to the third power times 3 times 5. This is your final answer. So I circle it just like that. All right? And that is how you do prime factorizations. Okay, let's find the greatest common factor of two different numbers. And let's do 27 and 42. Okay, so to find the greatest common factor, again, we have to do a factor tree. All right, everything pretty much includes a factor tree. So let's factor out 27 and 42. 27 factors out to be 3 and 9. 9 breaks down into 3 and 3. 42 breaks down into 6 and 7. 6 breaks down into 2 and 3. So if we circle everything at the end of our factor tree, those are our factors. So we're looking for the greatest common factor. So the one that both trees have that is the biggest. This tree has only 3s. This tree has a 2, a 3, and a 7. So if we find the biggest that both of them has, this one only has a 3, so this one has a 3, and that's the biggest. So the GCF equals 3. Done. That's it. That is how you find the GCF. Okay, so let's see if we can find the least common multiple of these two. So the least common multiple, remember, has 3 different steps. Do the factor tree. So we did the factor tree up here, all right? So then we can, step number 2, write out the multiplication problem. So 27 equals 3 times 3 times 3, which equals 3 to the second power. 42 equals 2 times 3 times 7. Okay, we can't actually do any smushing together there of the numbers. Step number 3, we take the largest power of each number, so we can cover up these numbers, and we can say we're working with 3s, we're working with 2s and 7s. All right, so the highest power, the LCM, equals the highest power of the 2s, which is just a plain old 2, the highest power of the 3s, which is a 3 to the, third power, because there's 3 3s smashed into that 3 right there. Okay, and then the highest power of the 7s, which is just a 7. All right, so now we actually have to do that math. All right, so LCM equals 2 times, what's 3 to the third power? 27 times 7. We're going to actually have to stack some multiplication problems here. So 27, let's focus on that right there. Multiplied by 2, 2 times 7 is 14. The 4 goes down here. The 1 gets put up at the top there. 2 times 2 is 4, plus 1 is 5. So 54 is 27. So then we have 54 times 7. So now we have just a regular multiplication problem. Okay, let's stack that one again. So we have the 54 here. I'm just going to write multiplied by 7. All right. You can't see that. There we go. Now we can see. 54 multiplied by 7. So the 4 multiplied by the 7 is 28. So 8 goes on the bottom. The 2 gets put up top. 7 times 5 is 35. Plus the 2 is 37. So 7 and 3. So the least common multiple of 27 and 42 is 378. And again, let's circle our final answer. Okay, we are going to have a test soon, so work hard on this and make sure that you ask questions.